Hello students, welcome to our YouTube channel Free Tutor. In this part of video, we will discuss some numericals based on chapter motion class 9th physics. So let us start. Our first problem is that the velocity time graph as shown in figure shows the motion of a cyclist. Find A, its acceleration, B, its velocity, and C, the distance covered by cyclist in 15 seconds. So we will solve each of these parts one by one. So let us see. Here from this graph, it is clear that this is the velocity time graph in which time is represented along x-axis in seconds and velocity is represented along y-axis in meter per second. Again from this graph, you can conclude that at time t is equals to 0 second, the cyclist has a certain velocity of 20 meter per second. And after 10 second, the cyclist has the same velocity of 20 meter per second. So if we want to find the change in velocity from 0 to 10 second, then we can say that the velocity changes by 20 meter per second minus 20 meter per second. Because here you can see at 0 second, the cyclist has a velocity of 20 meter per second. And after 10 second, again it has the same velocity of 20 meter per second. So from 0 to 10 second, the velocity changes by 20 meter per second minus 20 meter per second. That is 0. Or in other words, we can say that the rate of change of velocity of the cyclist is 0. And students, you know that rate of change of velocity is known as acceleration. Hence, we can say the acceleration of the cyclist is 0 because it is traveling with the same velocity along a particular direction. So we can write as velocity time graph is a straight line parallel to time axis, the motion is uniform motion along a straight line. Uniform motion means the object is traveling with constant velocity. Okay, so acceleration of a cyclist is 0. Now let us see second part. In second part, we have to find the velocity. So again from this graph, it is very obvious that the velocity of the cyclist is 20 meter per second because the cyclist is traveling with the same velocity of 20 meter per second along a straight line. Hence we can write from this graph, the constant velocity of the cyclist is 20 meter per second. Now let us see the third part. In third part, we have to find the distance covered by cyclist in 15 seconds. Now students, you know that the area under velocity time graph gives the total distance covered by an object or the magnitude of displacement. Since in this problem we have to find the distance covered by cyclist in 15 seconds, so first we draw a line parallel to velocity axis from the time corresponding to 15 seconds. As you can see, the line BC represents a parallel line to velocity axis from time t is equals to 15 seconds. And this line BC enclosed the area OABC, which is a rectangle. So this rectangle OABC gives the magnitude of distance covered by cyclist in 15 seconds. Hence we can write distance covered by cyclist in 15 seconds is equals to area of the rectangle OABC. And you know area of rectangle is length into breadth. So we can write area of rectangle OABC as OA, that is OA, which is equals to 20 meter per second into OC, which is equals to 15 seconds. So here we can simply put the values 20 meter per second into 15 seconds and it comes out to be 300 meter. It means that the cyclist has covered a distance of 300 meter in 15 seconds. So our problem is solved.